All right. So we've got this question. The curve y equals ax squared plus bx plus 4 has a stationary point at 1 and negative 4. Find a and b. I guess what's the general logic to finding a and b? Forget this topic. What would be the skill that you would need eventually to find two missing letters? Not necessarily, no. To find A and B. Think about your other topics. Think about in which case did you have two missing letters and what was the technique you used? Simultaneous. So you straight away should know this would require simultaneous equations. Cool? So if you need simultaneous, if you want simultaneous equations, how many equations do you need? In this case, two missing letters, you'll need two equations. Okay, so we know that it's a stationary point at 1 and negative 4. What does that mean? What does a stationary point mean? You said that again. I want to be specific. Don't say at 0. Say the word in front of it. You know that at stationary point, stat points, y dash equals 0. So what do you think I'm going to say to do? Differentiate. You've got to find y dash. Y dash equals 2ax plus b. What does x equal to? 1. What does y dash equal to? 0. Yeah, you guys got it right today. The ones that did it at home wrote what? What do you think they wrote? Negative 4. What does negative 4 stand for? Y, not y dash. Right? Don't mix up the letters. Y dash is equal to 0. There's equation 1. Yay. Equation 2, a lot of people now have problems with. How do we do equation 2? Right? How do we do equation 2? Let's see. There we go. How do we do equation 2? What are we thinking? 3ax squared. No, that's double I. Forget double I. We're doing only I right now. What do you reckon? Okay, I'll give you a clue. Somehow we would have to sub in negative 4, which means y value is negative 4. So what do you think I'm going to say to do then? If y is negative 4, x is 1. Don't overthink it. If it's a stationary point, doesn't it also mean that it's a point that lies on the curve? Isn't that true? Stationary point just means y dash. But isn't it a point that also lies on the curve? What do we do with point curves? No. What do we do with points that lies on curves? Wrong. Just points that lie on curves. If I said, show that a point lies on the curve, what would you do? Sub it in. So if it's a point that lies on the curve, just sub it in. So your second equation looks like this. Negative 4 equals a plus b plus 4. All right. And then you just solve simultaneously. I don't think we need to do that, right? That should be pretty straightforward by now. So what's the answer? Let's do it. A plus b equals negative 8. That's your second equation. That's your first equation. Everyone's okay with that so far? Everyone at home keeping up? Cool glasses even. I like it. All right, we're going to subtract 0 take away 8 is 8, 2a take away a is a, b take away b is 0. You just found a is equal to 8. Sub it back in. What is b equal to? If a is 8, b would be negative 16. Does that make sense? Yep. Make sense?
Yeah.
Any questions? No? Do you want to try double line? Yeah, just try it. Okay, well, let's talk about it real quick before you guys do it. Let's read. The curve passes through. What do we do? Sub in. Good. We're back. And has stationary point. What do we do? Y dash equals 0. And the fact that it's a stationary point, what can I also do? The S word you just used before. You'll eventually have to do simultaneous. Sub in as well. Don't forget, you can sub it in as well. So you should have 3 substitutions essentially. Go. Good luck. I'll leave it with you guys for just 2 minutes so I can sort everything else out. So remember, first thing you would do is just substitute because the point that passes through. Second thing you would do is also substitute. Third thing you'll do is y dash equals 0 and substitute x as negative 2. Some of you haven't sent me homework. For those who haven't, unfortunately, I'll have to contact your parents. You know the drill. I told you it was going to happen. So I'll still give you by tonight, 8 o'clock tonight. If it can be done by tonight, I will still accept it. That's it. Continue, and we'll talk later. We'll talk later. Those who sent it online, I accept it, so it's all good. You've already got my feedback, so all good. All right. Anyone completed yet? All good. Anyone's completed double I? No? Do you have one of the letters though? Yep, you should have D, I'm guessing. Good. Right. I guess my turn to get onto it. Let's have a look. Double I. Like this thing. All right, double I. Let's have a look. Let me rub out all this. All right. Double A. The curve passes through this, so I would have substituted 0 and 2 in. You get y as 2, x is 0, which means everything cancels out, and you would get d equals to 2. It has a stationary point at -2 and 46, so we know something. If it's a stationary point, right? It's a stationary point. It must lie on the curve, but we also know that y dash equals to 0. So we know two things, not just one thing. So we know y dash equals 0, which means y dash equals 3ax squared plus 2bx minus 36. Again, what does y dash equal to? 0. What does x equal to? -2. So it should look like this. Something like that, and then we'll fix this up. We get 12a minus 4b minus 36 equals 0. Yep, again we can see two missing letters. We know it's going to be a simultaneous equation. So then the second equation you guys need is your original one. The fact that it's a stationary point, I guess I gotta keep saying it because everybody keeps forgetting it. If it's a stationary point, it also lies on the curve. So just sub it in. Sub it in. 46 equals a -2 cubed plus b -2 squared minus 36 -2 plus d. And then that becomes -8a plus 4b plus 72 plus d. But what does d equal to? 2. We've already found that out, so you might as well substitute that. And again, we're back to equation 1 and equation 2 when you fix it up. So I am going to fix it up real quick and I'll leave it with you guys to finish off. 12a minus 4b equals 36. And this one, -8a plus 4b equals 46 take away 74. 46 take away 74, -28. Where are we? -28. And then solve those two simultaneously. Is that okay? Joe, you alright with that as well?
Yeah.
Cool. Any questions? I'm still talking. Finish it off if you can while you're here. Give me an answer for A and B. To solve them simultaneously, you're probably going to add them, right? Because the 4b's are the same. What did you get, Eden? A equals 2. 12, 8 is 4a. 36 take away 28 is 12. No, it's 8. Sorry. 8. Which means A equals 2. Good job. And have you found B yet? B is -3. Anyone agree? We'll wait and see. Let me check it as well. 24, 36 take away 24 is 12. Looks good to me. Sub it back in, and you should solve for b as -3. Saturday class, those who have joined, you don't have to worry about the homework. Yours is due on Saturday, so don't stress. I forgot to say that. It's only the Thursday class that's due today. Might have scared a few people. Sorry. All right. All good for move on? All right. Good. So continue from here. So we said this 22nd October. Yep. Sounds good. At a point. Okay. Let me just see what we've got left. All right. This isn't part of the I guess the max min problems that I was talking about last week. That's going to be hard. This is just something we said we're going to continue from this week. So page 15. Have a quick read. Maybe think about it. I'm just going to go grab your two booklets. Oh, thank you. Thank you.
Doesn't B squared IPC combined with that?
Yeah. Have a think about it. What does it mean? What does y double dash mean when it's like that, or like this, or y dash? First one's the classwork, of course. Second one's the homework. First one, that one there, is the classwork for you. So we're on page 15. All right. Let's see how you guys do with this question. All right, at a point 3 and -2 on a curve, dy dx, which means y dash, is equal to 2. Okay, and y double dash is equal to -1. That's very specific, but you don't care about the number. Because like y dash being 2 just means the gradient is 2. What if the gradient was 3? What if the gradient was 5? What if the gradient was 10? What if the gradient was 20, 30? Does it make a difference? Mathematically, yeah, the gradient's getting steeper, but is your increasing or decreasing factor going to change? No. If y dash is greater than 0, you say it is? No. Y dash, anyone? Greater than 0? Increasing. Thank you. See how you're already falling behind? You're not revising. You don't want to restudy. Y double dash, if it's less than 0, because if it's -1, if y double dash is less than 0, opposite of what your brain might think. So if less than 0, you would think it's min. Opposite. That's what I was trying to help you with. So think that one's an opposite. Max. So now you want a maximum increasing at 3 and negative 2. Did anyone actually realize that? Thanks for your honesty. Maybe a little bit. Good. Okay, that's good. Anyone at home realize that? That's what you needed to do? All right then. Let's go. X is 3. Y is negative 2. There it is. It's going to be an increasing maximum. Well, you guys know maximums look like this. Which component of this is increasing? The left or the right? Obviously the left. So here it is. Done. Finished. That's the curve. Isn't it increasing always? And isn't it part of a maximum? Done. So the 2 is irrelevant. The negative 1 is irrelevant. Stop getting fooled. Next page. Well, obviously these guys got arrows, right? But that's it. I'm going to give it to you guys one more time. Don't look at it and be confused. Don't worry, just take your time with it. Write down what you know. What do you know about y dash being less than 0? What do you know about y double dash equal to 0? What do you know about y double dash greater than 0? And what do you know about y double dash less than 0? Just have a quick think about it. And if anyone wants to say any words that they know, we can start writing it down for all of us. It will help. So, any words that we know? Decreasing, I like it. That's that one. Equal to 0?
Min or max.
Min or max, incorrect. I don't think you can say just possibility. You actually can say now. The other word, not possibility. Possible what? Yeah, you can actually say it is a point of inflection. You're only saying possible when you're doing your math. In this case, you can just say it's a point, because they've already told you it is equal to 0. So we're going to say point of inflection. Good. And then it's saying for when it's less than 2, it is y double dash is less than 0, which means max. We're back. And less than 0, no, other way around. Greater than 0 is a min, opposite of what your brain might think. Less than 0, when greater than 0, it's min. When it's less than 0, it's max. Y double dash, but don't say just it is. Say y double dash less than, because you keep saying it is. There's two things, there's y dash, y double dash. Can't say it is. All right, let's sketch it. All right, so I mean, here's your coordinate. So you can see a lot of the work was not part of the sketch. You guys read it as sketch. Oh, Sam, I don't know how to sketch this. It's got nothing to do with sketching. You have to interpret all those y dash and y double dashes. That's what you've got to do. When you've done that, go and put where 2 is. 2 is right here. 2. Just put it anywhere. It doesn't matter. There's no y value. If there's no y value, it doesn't matter where it is. No, there's no y value, so put it there. There's your 2. Happy? It's saying that when it's less than 2, it's a minimum. If it's greater than 2, it's a maximum. Think about the diagram. Less than 2, minimum. Greater than 2, maximum. And at 2, it's a point of inflection. And the only difference, and the only difference between it is the fact that this bit here is decreasing. So it can't be doing this. Because that looks like that's a maximum and then a minimum. Doesn't it? Max and then a min. It should have been a min and then a max. So it's this way. Can we see it? Minimum, you had that?
Yeah.
Beautiful. Yeah, beautiful. Minimum on the left, can you see it just one more time? Minimum right here, look, min, and then a max. Decreasing. Not hard. The sketching's not hard. But everyone emphasizes on the sketching. It's not the sketching that's the problem. It's the interpretation of y dash, y double dash. And stop getting lazy with it. Don't just say, oh, greater than 0 is this. Say y dash greater than 0 is this. Y double dash greater than 0 is this. Good. Hey, look, by the time you guys do this at school, it'll be easy. But it should be easy here. So when you're at school, you don't even have to worry about it. You should just be doing exam questions. Yeah. All right. Let's try another one. Hopefully our last one before our max min problems. Yep, looks good. Last one. Example 20. Again, have a read. Cut as much as the words as you can. Ignore it. Remember, you're in advanced math. What are the words I'm looking for? Like not specifically there. Just what are the words that we've done in this topic that I'm technically looking for? Rate. Y dash. And y double dash. So I'm literally looking for y dash and y double dash as much as I can, because then that will tell me it's increasing, decreasing, and maximum, minimum. Sounds good? As you're reading. If it's growing, what does that mean? Sorry? Beautiful. See, logic, it's coming back. Increasing, this guy means it's increasing. And we know increasing means y dash greater than 0. Saying cut the crap. Right, there you go, done, since 1980. But the rate of growth has been decreasing, and that's something I do want to talk about today. But does anyone actually understand what that bit means? The rate of growth has been decreasing. Yeah, the rate is, so what Tiana just said is the rate, or the population, let's say that word because it's probably better, the population is increasing at a slower rate. So do you guys understand that concept? So think of insects. Right? If insects were to multiply, you would think they would multiply exponentially. So they would increase faster. Does that logic make sense? Now imagine all of a sudden I introduce a poison, right? That would kill off 50%. Well, what happens is they're still going to multiply, right? They're still going to increase. But as they are increasing, they're also dying out, which means they're increasing at a slower rate. You see that happening? And I'll actually show this graphically. So that's what I skipped last week. I wanted to introduce it this week because I think it makes sense in the second week. So if something is decreasing, if the rate of growth is decreasing, then that means y double dash, if it's increasing at a slower rate. It's increasing at a slower rate. It should be a maximum. So it's y double dash is less than 0. And you'll see that in a second, why that makes sense. So just give me some time and you'll see what that means. Don't think decreasing, do not associate decreasing with y double dash less than 0. So don't think I looked at decreasing, maybe I drew that arrow in a bad place. It's not really meant like that. You will see what I mean once I draw the graph. And you'll see how that's different if it was a minimum. Cool? But this is the graph. Look, it kind of makes sense, right? This is 1980. We had 3,200 individuals. There they are. True? Isn't that what you would have drawn? 1980, 3,200 people. They are increasing. So I would have drawn this. So there's two graphs. There's this graph and there's this graph. This, I'm going to only highlight the increasing bits. That's increasing and that's increasing. True? Which one is increasing slower? Again, think about the rate of growth. This is increasing. I'll grab it 2 minutes. It's increasing fast. faster and faster and faster and faster and faster. Can you actually guys, can you see that? It shoots up forever, so it's actually a lot faster. Whereas look at this, it's increasing, 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 eventually has to slow down because it hits its maximum point and then shoots down. So this is slow. This is fast. What about the two parts that I haven't highlighted? Which one's decreasing faster and slower? Well, again, think about it. Is this one faster or slower? Is this decreasing faster or decreasing slower? What do we think? Again, start from up here and think what happens. Slower. Why? Because it's going to start increasing again. So it's getting its lowest point. It's going to slow down. That is very slow. Look at this. Decreases, decreases, decreases. Goes through the ground. Right? It smashes the ground. It's fast. That's how you can see it. This is really fast. That's the best way to see it. I didn't really look at it as decreasing like the word decreasing. I saw it as it's slowing down. So then, once I know that, there it is. Finished. And yeah, and then it says it eventually stabilizes. You think so, but then obviously with the pandemic that we're going through, all of this has been used, right? So many mathematicians have got a job all over the world. Finally, no, look, it stabilizes at 8,000. I think Eden, you were drawing it. Stabilizes means, yeah, not stationary, asymptote. Asymptote. It's it's not going to go past 8,000. It's going to reach what? 8,000. Right? It's reaching 8,000. Eventually, if the current trend continues, the population will eventually means as time approaches, infinity. Right? Eventually. When's eventually? Hey, Tiana, I'll eventually see you. When's that? To you, it's like infinity. Stabilize at a size of about 8,000. There we go. Hardest bit, I think, is the increasing and decreasing faster and slower. So let's just review that one more time before we start the heavy duty stuff for today. I keep scaring you with that, but it's not that bad. I'll make it really good, but we'll see. Let's go back. Let's just have a quick look at this. Here it is. That's pretty much all the graphs you're ever going to see. So if you see it, if y dash is greater than 0, which we know is increasing, decreasing, stationary point, greater than 0 we know means it's so you're thinking max, it's opposite. Min, this one's a max, and this is a point of inflection. This is on page 13. So this one, increasing faster or slower? This is the first one, fast. So now you just learned, and I don't want you to memorize it like this, but you just learned if the y dash is greater than 0 and y double dash is greater than 0, then it's increasing the fastest. But I don't want you to memorize that. I actually want you to understand it from the graph. So if I ever had one, I would have quickly drawn these two. And I'll say, okay, which one's increasing? This side's increasing and this side's increasing. Which one's faster? That's it. You're not going to memorize all 9 of these. Nobody does that. So it's just silly. But it's better to understand what you're doing. Next one. This one's decreasing. Decreasing at a slower rate. Good. And obviously that's a stationary point and it's a minimum. The ones we know. This one, increasing, but slow. So slow. This one, decreasing, and as I said, it shoots into the ground, so it's super fast. Yep. This one, only increasing. But it's increasing what? And then what?
Increasing fast.
Fast. Look. Fast. Then it slows down. Slow. So if he ever says that, if he says Sam's riding his bike, he goes down a hill, what's going to happen? It's going to be fast. and then something happens, and then all of a sudden he has to climb up the hill. It's going to be really slow, but I'm still climbing. So I'm still increasing. Good. Good. Yeah, you're all getting it. I'm making you get it. And I want you to do the same thing when you're at school, you're looking at questions. Just remember these days, you're like, I used to get it. So then that means you're doing it in a weird way. So talk to me and we should get through it. Decreasing, again, same thing. This is the fastest and this is the slowest. And then these are points of inflections or horizontal points of inflections. These are called horizontal points of inflection. Any questions? Everyone at home keeping up? Chan, can you confirm all good?
Yeah, just draw a graph.
Drawing the graph, okay. You come in on Wednesday, I think. I'll print the booklet for you so you can just copy everything to that as well.
Thank you.
All right. I think we're going to page 20. Chan, just let me know when you're ready to move on.
Yeah, I'm ready.
Yep. All right, page 20. So, this is it. This is the last bit of this topic. There isn't anything else to learn. So what's everything that we need to know? We need to know stationary points, nature, two ways, points of inflection, prove them as well, sketch the curves once you've got your stationary points and points of inflection, note increasing, decreasing, maximum, minimums, derivative graphs. That's what we also did last week. ISP, intercepts, stationary points of inflections, we're going up. So that, and then the last bit of it is what's called max-min problems or maximum-minimum problems. Don't underestimate this exercise. This exercise is going to be the last question of the HSC. So on Monday, that's coming up, I've already told them it's going to be this topic. It's 100%, it will be this topic. So it doesn't make any sense to me, nor to yourself, to ignore this topic just because it's hard right now. Tackle it head on. Because if you can get these 5 or 6 marks, you know your friends at school can't. Because this one's not easy. This one takes about a year to master for a lot of students because they ignore it. They just go, it's too hard, I'm leaving it away. They fail it in their first exam, comes to their trials, they'll still fail it, and then they try to pick it up with the HSC. Don't. Ignore it. So we're going to spend a good, I don't know, until I feel like you guys are getting it, I guess, 3 weeks, maybe 4 weeks. I'll make it easy, right? I'll make it easy, as easy as I can, but it means nothing if you guys don't go back and revise it. All right? I've written the steps. Step 1, we can sometimes ignore, but step 1, draw a diagram if the diagram is not there. The harder ones, the diagram is usually there. Step 2, introduce 2 variables from which the function can be formed. Step 3, form an equation in the 2 variables, noting any restrictions. Step 4, just do stat points and max min, so do your nature. Step 5, answer the question. So, sounds weird, but I'll simplify it yet again. Step 1, for us, 2 equations. How about that? Step 1, 2 equations. One needs to have 3 variables. One needs to have 2 variables. So 2 equations, one's going to have 3 variables, one's going to have 2 variables. You're going to make 3 no, from 2, you're going to make it into, you're going to make 1 the subject, make 1 of the variables the subject. Does that make sense? So make 1 the subject, sub into this. So how many variables would you have now if you're subbing that back into the 3 variables? 2 variables now. So you just made 3 variables into 2 variables. Yeah, no. It looks complicated like this, but again, once you start it, you'll be like, okay, I think I can do this. So one more time, I'll start from the top real quick. You're always meant to have 2 equations. Sometimes they give you 1 of them, great, that's better for you. The harder ones, they usually do, but then the math is really hard. The easier ones, the math is easy, the first step is hard. So this is the first step. You need 2 equations. 1 with 3 variables, 1 with 2 variables. The one with the 2 variables, you'll make 1 of them the subject. Once you make 1 of them the subject, you'll sub that variable into the 3 variables. Your 3 variables now become 2 variables. Now that you've got 2 variables, you can obviously differentiate. Because when you have 2, like y's and x's, you're allowed to, if you've got y's, x's, and z's, you can't differentiate, you've got 3 letters. So you're meant to always differentiate a 3 variable one. So 2 variables, now stat points and nature, and you're done. Answer the question, finished. So the stat points and nature is easy, right? That's going to be nothing, as you can see. It's step 1, that's the problem. I said step 1, and that is all step 1. There's only 1 step. You've got to know it's 1 big step. 2 equations, 3 variables, 2 variables. Eden, you had a question. What's a variable? Pronumerals, letters, X, Y, Z, A, B, C's, whatever the letters they choose. All right, let's start again. A farmer has 30 meters of wire fencing. A farmer has 30 meters of wire fencing. Oh, every piece of information in this topic is important. So you don't ignore really anything. So if it says 30 meters of wire fencing, you're going to use it. She wants to make a rectangular enclosure using the wall of a barn as one side. So there's the wall that's already there. That's already gone. So we don't need to include that. And you want to make a rectangle. Can we see that happening? What is the largest area she can enclose? That's all it says. All right. This is actually really important to learn. It's a really important skill to be able to maximize and minimize areas, volumes, profits, cost, time spent on the traffic light, and so on and so on. You can get this really gets endless. So really important skill to learn if you can apply it into your real world. So for example, like architects, if architects actually understood maximums and minimum problems, they would maximize space but keep the same material used. So I'm going to show it to you in this particular example. I've only got 30 meters of fencing, right? And I've got 3 sides I need to close up. So let's just say I did this. I went 5 here and 5 here. That's 10 meters I've used. You guys don't need to write this just yet. And that's 20 meters. What's the area I've got right now? 100, which I'm happy with. I did it. I did my job. 100 square meters. Cool. And then Tiana comes up to me and goes, "But Sam, why did you choose 5? Because I think 6 would have been better." I'm like, "Wait, what? As if it makes a difference. I've only got 30 meters of fencing." I've only got 30 meters, so what if that's 6 and that's 6 and that's 18 now? What's 6 times 18? And she's like, but Sam, 6 times 18 is 108. I'm like, wait, what? How did you just get me 8? 8 square meters more. That's a lot. You guys know what I'm saying? 8 square meters, that's a decent sized room, right? So 8 square meters by just increasing one length by 1 more meter and reducing another length. Okay, then again, Eden comes in and goes, no, Sam, I think it should have been 7. 7, 7, and then that's what, 14? And then it should be 16. What's 7 times 16? 712. Yeah, even larger. Now, obviously, you can't just keep doing that because it's going to be a turning point, right? It's going to hit its maximum point, then it's going to come back down. So the curve technically does this. That's why you've learned parabolas. And you guys are like, oh, this is useless. The idea is it actually works. It's just, you've got to learn the application. We want to find this maximum point. We want to find the maximum area, the largest area. Because why not, if I can, right? I've got 30 meters of fencing. I might as well maximize it. That's what I talk about in terms of architects, for example. We're talking about floor space. They could have just done 7 meters instead of 5 meters. All of a sudden, you've got a bigger room. Still going to use the same amount of paint, same amount of gyprock, same amount of timber, same amount of everything. Everything's the same. You've got more space. So let's find the maximum area. Let's see how these work. Okay, we need 2 equations. What do you think those 2 equations are? One's going to start with P, one's going to start with A. A is obviously area. P is perimeter. Perimeter is how much? What does it say in this case? 30 meters, right? I know the perimeter must be 30. So I've got 2 equations. One's area, one's perimeter. Happy? I did say one of them is going to have 3 variables. Well, this is x and this is y. Area equals x times y. But you know the perimeter is 30. And that 30 is meant to be x plus y. 30 equals x, or 2x plus y. Can you see how now I've got one equation right there with 3 variables, 1, 2, 3. I've got another equation with 2 variables, which means something was given to you. So they'll give you that. Still good? What do? From 2, make one of them the subject, sub it in. Obviously, which letter am I going to make the subject? Y. Right? Because it's just by itself. So 30 take away 2x. So far so good? What do I do with that now? Sub it into y into here. Yeah, exactly. So A equals x times y. There we go. Technically, you guys that are looking at this going, oh, what is happening? Isn't this just like what you've been doing your whole life? Y equals 30x take away 2x squared. That's just a parabola. The thing is, you don't have the equation. That's all. We are creating the equation. And that's what's hard. So exactly the same. I'll just write here. Same. So you're going to do everything the same. You're going to stat points, nature. There are no points of inflections because you don't want to find where you can find the largest area that then goes to the minimum area. That's not what you want to find. The points of inflections are obsolete in max-min problems. They don't exist. All we're interested in is stationary point and then its nature. Because then stationary point tells me its highest or lowest point. So here we go. Stat points. Y dash equals 0. You try to refrain from using A dash. Your teachers might. Technically, dash is only reserved for Y. So mathematically, we only use it for the Y's. So A, you can't write it. You've got to go back to D. dA on dx. equals 30 minus 4x. What must it equal to? What must this equal to? 0. So therefore x equals to 30 divided by 4, 7.5. Now that you found that, that's great. The question actually said largest, and then it said area. We haven't found area yet, but it said largest. How do we know if that's even the largest? You just went and did y dash. So you've got to prove its nature. You've got to make sure it's a maximum and not a minimum. Because if it's a minimum, there's a problem. So nature. Nature is y double dash. Y double dash is negative 4. What is negative 4 always? Less than 0, which means max. Therefore, max area is 30x take away 2x squared, 30x take away 2x squared. 112.5 is the maximum area you're ever going to get making a rectangle with 30 meters of fencing. And they sent you here. Fair enough. So let's recap that. We had two things they gave us. One was it said to find area, so I knew straight away I have to have an equation for area. They gave us perimeter. I plugged that in, and then made two variables into one variable, substituted that one variable into three variables. Three variables became two variables, differentiated, made it equal to 0, made sure that it is a maximum, so I'm finding the largest area, not the minimum area. And then that's it, you're done. It just said find the max area, so therefore max area is this. Yes?
When this is a equals 30x times 4x squared, how is it the same thing y equals 30x times 2x squared?
Sorry. Y, maybe this y and this y, you're going to get confused. Is that the reason? This y and this y is not the same. I meant it's the same as your y's that you were doing with parabolas. That y. Like I'm just saying it's just a parabola. So don't overcomplicate A. A is just the same as a y, but yeah, I will call it y1. 30x 1, so that we know it's not the same as the top one. All good. All right, let's go. Let's do another one. Example 24. Find two numbers whose sum is 28 and whose product is a maximum. All right, what do you think you have to start with? Sum is 28. Lissandra, what do you think I'm going to write?
See, as in 30.
Sure, and then the sum of two numbers is 28 though.
So x.
There we go, that's better. X plus y equals 28, and you want the product to be a maximum, so you want to find the P, the product, which is equal to x times isn't it?
Yeah.
The product to be x times y. There you go. I've got my two equations. Isn't that just another way of saying area and perimeter again? The perimeter is 28 and area is max. Go ahead, try that. So from this, make one of them the subject, sub it in, differentiate, and let's see if you guys can get the same answer. Or find the maximum product if you can, of two numbers whose sum is 28. All right, as you guys are working, I'll do a few lines as well. I'm going to make y the subject. It doesn't matter which one you make the subject. There it is, sub into here. And then step points, dp on dx equals 28 minus 2x equals 0. Anyone have any questions? No? We'll continue. X equals 14. Again, great. You found out the x value, which means you can also work out the y value, which is also 14. It's good, but so what? What must you also do? Nature. You have to say it's a max. Otherwise, you didn't prove the product is a maximum. So we're going to go nature. There it is. Equals, in this case, it's just -2. Again, what do you know about -2? It's less than 0. Y double dash less than 0 is a max. Therefore, max product is x, which is 14, times 14. It just says find two numbers. Sorry. The question doesn't ask for the product. It just says find the two numbers whose sum is 28. Therefore, two numbers are 14 and 14. Such that they sum to 28, but their product is also a max. All good? Any questions? No? Eden, maybe? You seem like you have a question.
How is the curve of 14 14
What do you mean? So what you've just done, you went and created an equation for the product, which is a constraint with x's, right? You first worked out that it's a constraint with x and y. Then you realized that you could just do it in terms of x's from this relationship. Then you went and differentiated. So you found the critical point. You went and found your stationary point. And you found that that stationary point is a maximum. So the maximum value you're ever going to get for your product is when x is 14. The maximum you're ever going to get for this curve is when x is 2 or 14. The maximum that occurs is at 14. That's what you're literally finding. When that maximum occurs. Does that make sense? Okay. Now I'll give you the biggest product, which is 14 times 14. And that's it. That's all you can get from two numbers adding to 28. So that means 10 and 18 is not the largest product. That's what most people would go for. I guess if something added to 28, they'll go with 10 and 18 or 13 and 15. But it's actually 14 and 14. That will give you the largest product you can ever get. That's it. Can't get bigger than that with two numbers added to 28. A silo in the shape of a cylinder. Don't stress what a silo is. It just tells you it's a cylinder essentially. But a silo, usually is meant to be a cone. But anyways, a silo in the shape of a cylinder is required to hold 8,600 cubic meters of wheat. That means what? What letter is that? V. I like that. There we go. Now it's time to see how these work. So now you know you need the volume of a cylinder. And that's going to be equation 1. True? You need the volume of a cylinder, but they've given you equation they gave you the amount. That's technically equation 1. Find an equation for surface area in terms of the base radius. Cool. So just take your time. Let's write the first thing. The first thing I know is V What's the volume of a cylinder? You were very close. It's not 2. It's just pi r squared h. 2 pi r squared is the circles. 2 pi r h is the curved. I won't be able to help you. I won't be able to help you. Is it because you were naughty? You got moved here? Yeah, maybe go back to that class and see if you can stay back there. Don't come back in here. Avoid becoming back in here. Okay? I think be a good boy. V equals pi r squared h. Okay. And it says surface area. You were saying, Fiona, surface area is 2 pi r squared plus 2 r h. Because the 2 circles and the curved bit times h. Yes, you do need to obviously memorize some of your formulas for this topic, which is why everyone's like, oh, I hate this. Because there are a lot of formulas that you thought you didn't need. And you don't. Yeah, you don't necessarily need it, you just need to memorize it. All right, here we go. It says find an equation for surface area in terms of the radius. So what letter technically has to disappear here? Sorry? In terms of, the radius. So what letter has to disappear here? H. So if H has to disappear, isn't that the step I already told you have to do? I said you're going to have 2 equations, and then from one, make it the subject, sub it into the other one. But for harder questions, they usually walk you through it. But you guys should already know that. So to you, it's irrelevant telling you it's in terms of the base radius. Because you already know I have to make it in terms of the one letter, or the 2 variables in this case here. All right. So volume's given, 8,600 equals pi r squared h. Isn't it? So what does h equal to? 8,600 on pi r squared. Good job. And then sub it in, and you're done with I. You found the surface area in terms of just radius, just r. Pi and pi cancels, r and squared cancels. 2 times 86 is 16, 17, 200 on r. Make sure, 17, 200 on r. Yep. Done. Usually worth 2 marks in your exam. 100% will be in your first exams. So the ones that are in your year 12, your first, this term, this exact term, you have this topic, this will be the question. Will be in your test. They give you one, this is meant to be easy. They'll give you one easy one, and they'll give you one ridiculous hard one, which are the band 6 ones. This one is meant to be easy. Meant to be, because it becomes stock standard. Find the minimum surface area required to hold this amount of weight. Again, now it tells you we want the minimum surface area, so we don't want to waste too much metal making this cylinder. Right? We want to minimize our usage. Okay. So, don't you already have an equation? Let's just make it into A. It makes it a lot better when it's area now instead of SA. Don't we already know the expression? It's right there, 2 pi r squared plus 17, 200 over r. So what am I going to do? I'm going to obviously start. What? What do we do once we've done that? Start point. You just start differentiating and finish it off. Don't be afraid. Once you've got that equation, that's the hardest step. Once you're up to there, you do that, the rest. Before you can do your stationary points, what don't you like about that equation, or the way it looks?
The fraction.
The fraction could work. So before I start, I'm just going to do this. There it is. And then now we do it. dA on D.
X.
What letter do you see?
R.
R. dA on dr. Makes sense. Good. Equals 4 pi r minus 17 to 100 r to the negative 2. Yes, you need to be really good. Sorry? You are. Because we're going to make it equal to 0. Equal to 0. 4 pi r minus 17 to 100 on r squared equals 0. How do I get rid of the r squared? Times everything by r squared. Becomes 4 pi r cubed minus 17 to 100 equals 0. How do we solve for r in one line? Say it. Say it, Eden. Yes, say it. Plus 17 to 100 divide by 4 pi and then cube root. Here we go. You have to do it in one line. Plus the 17, divide by the 4 pi, and then you got to cube root it. Right? That's just simple equations that you've done your whole life by now. You don't want to overcomplicate this step. Over 4 pi, and then that has to be cube rooted. If you couldn't do it in one line, do it in 3. But you'll run out of time in your exams. So you've got to learn to do it in one line. Extension kids are getting it done in one line. You guys got to get it done in one line. You don't want to run out. Done. That's all good. What's the problem? All good, like it's the correct answer, whatever. Yeah, who said that the radius is, that's going to get you the minimum surface area? It could be maximum area. It could just be anything. You have to actually go and do nature now. Now this is when you've got to ask yourself, do I want to differentiate this a second time? Or do I want to use my y dash table? So it's up to you. The second derivative is not as bad, but this is what I was talking about. You'll know what you want to do. As you do questions, you'll know which option to take. Let's do nature. Nature. I'm going to do the y double dash still. I can see it can work, and it's okay. 4 pi r. What happens when you differentiate 4 pi r? You're going to have left with just 4 pi. And then bring the negative 2 down. You're going to have plus 34,400. And then r to the negative 3. Correct? And then let's see if we all can understand what I'm about to say with this next line. Look, this number here, is it always positive, always negative, or we're not sure? So you reckon it's sometimes going to be negative?
Has to be, well,
I think
has to be positive.
that number is always positive because 17,000 is always positive. Divided by 4, which is always positive, pi is always positive, and you're just cube rooting it. So it's actually always positive. Now I know this number is always positive, which means what is 34,000 divided by a positive number? Positive plus positive. So I think we can conclude this is always greater than 0. Which means min. Read, and then remember step 5, when I wrote it up here before, as funny as it sounds, answer the question. Everyone forgets when they do all this math, they forget you've got to answer the question. What was the question? Find the minimum area. You didn't find area, you went and found radius. So to find your area, now you've got it right there. There it is. You actually know what r is. You plug that into your calculator, plug it in here. Let's find. Therefore, min area equals, I will do that for you guys. But if someone wants to double check it, you can. I'm just going to first plug in R, cube root it. R is about 11.1. 11.1 R. I'm going to sub that into A. But as you guys know, I sub in the exact answer, so I'm not rounding. All right, and the area is 2,323.7. That is the minimum area that I can make a cylinder that can hold 8,600 cubic meters of wheat. Like I said, to the everyday person, this means nothing. But to the manufacturing company that is actually making this worldwide, they obviously want to minimize their surface area, because that means less wastage, less material, less cost for them, more profit for them. Right? Because it can hold the same amount. So think of water tanks. Water tanks come in a whole array of sizes that hold the same capacity. But some that have understood math have gone, okay, we can hold the same amount as others, but have less plastic weight, use less plastic, and we can still charge the same amount because it's the same size. So therefore they make greater profits to the company next door who says it sells the exact same, blah, blah, blah. And you get it, like I said, math is very complicated. You've got to really understand math to be able to use it in your real world. And that's the only thing I can ever say. Let's get back to this. How are we finding it? What's the hardest step? Seriously. I think initially. For me, it's initial. I'm okay with differentiating, and so I feel like over time, over 2, 3, 4 weeks, your hand, your eyes, your brain gets used to differentiating again. You'll get used to the algebra. You'll learn how to do your equations again. The beginning, if you don't know how to start, double I won't even exist. So you've got to really master your eyes. All right, let's keep going. HSC question, 522. Okay, this is when you see HSC, it means 9900. So we're talking about if you're going to get a 99 or 100 in your HSC, everything else is already perfect. So when you're going to see this, the math is going to be hard. Right? I think. I'm just telling you, I'm giving you the heads up. If you see the math is hard, don't do what I said you might do at the beginning of the exercise, which is ignore it. Don't brush it off. Don't move it away. Don't go too hard. It's going to come back and bite you. And then you're going to try to learn it, but you're going to have battle scars and you're like, I don't want to do this again. So tackle it right now. There's only 2 topics that are really hard in Year 12, and this is one of them. The other one is called superannuation and loan repayments. Once we get through those 2, you guys are going to find everything else okay. So just don't run away from it. That's all I can keep saying. All right, have a read. It's complicated, it's weird, but maybe you'll be able to scab some marks. Just read it. Who can tell me why I keep saying this topic is hard? Like from what you've just realized from the last 4 or 5 questions.
There's a lot of stuff.
There's a lot of stuff. What do you mean? A lot of components. Okay, cool. Yeah. What's your thoughts? You have to get an equation from a worded problem. Fair enough. You'll get used to that actually, because once you see the word area, you straight away start going area. All right, area of this formula. If you see the word cylinder and you see volume, cubic, like volume of the cylinder, you'll get used to those. Believe me, you will. I think what's hard, or what was hard for me when I was learning this, good thing is I didn't have to do advanced. So when I got taught this, I was like, thank God I don't have to worry about this. But when I did get taught this, what I found really hard was the different questions. You've seen, we've done 4 or 5, and they haven't been the same. And they're not going to be. Why they're hard. That's why superannuation and loan repayments are hard. Because It could be Bob today, it could be Mary tomorrow, it could be Jane the next day, and each person borrows a different amount, does different things, their lives are very different. So questions can get very complicated. Same thing with this. No question is going to be the same. So you really have to expose yourself. All right, sorry, go back to reading it. I'm going to get started on it right now. Is that Luke? Yeah, he loves animals. Yes, last term was save the turtles. Now it's save the pandas. He got the pandas. An oil rig. All right. An oil rig S is 3 kilometers offshore. Full stop. Just stop. Don't read the whole thing. You guys have heard me say that before. Full stop means stop. So stop. Let's have a look at the diagram. Yeah, makes sense. You can see it's 3 kilometers offshore. A power station P, comma, means also pause, look at it. Cool. Is on the shore. Yep, makes sense. Look at the shoreline. Yep. A cable is to be laid from P to S. So from P all the way to S. Right, I think I get it. Full stop. It costs $1,000 per kilometer to lay the cable along the shore, and $2,600 per kilometer to lay the cable underwater from the shore to S. We understand what's happening? So if I'm on land, it's going to cost $1,000. If I'm in the sea, more complicated, so it's going to cost a little bit more. Right? That's pretty much essentially what it's trying to say. The point R is the point on the shore closest to S. So R is the closest. Yep, again we can see that. You see how I keep stopping and I'll go back to the diagram? That's how you read. And the distance PR is 5. Cool. The point Q is on the shore at a distance of X from R as shown in the diagram. Okay. Find the total cost of laying the cable in a straight line from P to R and then in a straight line from R to S. What? So easy for 1 mark. So what is it going to be? What's the total cost from P to R?
5,000.
Yep, 5 times 1,000 plus, obviously, 3 times. Oh, no. Because you're going to the sea.
2.6.
Yeah, 2.6, 2,600. You do some calculation work, should give you 12,800. And that wasn't bad for 1 mark. And just as a general rule of thumb, for the HSC, which is worth 15 marks, the last question, as in it's broken up into 2 parts, that's part 1 and there's another part. We'll see how many marks is this anyways. 6, 7, 8, 9, 10. That's 10 marks already. So the other part was only worth 5 marks. Other question. Yeah, 10% of the HSC in 1 question, right? But anyways, if you guys can get 7 out of 15 in the last question, you're already looking at advanced 6. So if we can get 7 out of 10 here, irrespective of what the other question would be, you're looking good. And you can see, we can scab a lot of marks. So that's 1 mark, nice and easy. Find the cost of laying the cable in a straight line from P to S. From P to S. So draw it. All right, what do you think you've got to do? What do you see? Pythagoras trig, more Pythagoras. Look at it, 5 and 3. True? Yeah, Pythag. But you guys didn't see that if I didn't draw that, so draw it. Yeah, good. All right, I think it gives you about 5.8. Yep. And obviously, what's the cost? What's the cost if I do it just from P to S? 5.8 times 2.6 again. Good. 5.8 times 2,600, right, guys? Because I'm going into the sea. This is the sea, so that should give you, if you haven't rounded, it gives you 15,160. 15,160. If you have rounded and you used my 5.8, 15,000, yeah, you're short by 80 bucks. Don't round. I'm just rounding because I can. You guys can't. I'm special. I did forget about Jamie, I just realised. He wants the password. Yeah. Gotta be organised before. Let's see. Be the total cost of laying the cable in a straight line from P to Q and then in a straight line from Q to S. Show that the cost is this. Okay, I think we got this. I think we got this. I actually do believe you guys have this. So tell me the distance from P to Q. What would that be? And you can see, before you say it, you're about to say it, you can see answers here, right? Answers there. You guys have taught you that already from last year, like it's there. So, Eden, go ahead. P to Q is 5 minus X, right there. Beautiful. And then, what do you think the answer to Q to S is, miraculously, without even doing any math?
56.
I'm not going to say that number. Square root of?
X squared plus
Yeah, square root of x squared plus 9. Without even doing any math, I know it's that because 2.6 is the 2,600 business, right? They took out 1,000. You're done. So cost equals 1,000 times 5 take away x, 1,000 times PQ on land, plus 2,600 times the Pythagoras fee. How did you find Pythagoras? X squared plus 3 squared, and then square root. And then obviously what did they do with that line? They took out 1,000. I'm just going to do it like that because I think you guys get it. You just take out 1,000, factorize 1,000, and then write the answer, literally. Everyone's good? Tiana, makes sense? Not bad, right? You got 4 marks at the end of the paper, really just given to you, which is good. And they do that. Just be open to it. Okay, now that you've got your 4 marks, the next 6 marks are going to be not as easy as them, probably. What does IV say? Find the, so what are you going to do to your triple I? Differentiate, and then eventually you have to prove it's a minimum. That's it. So I need space for that, obviously. We're going to go down here. IV. Let's scroll it up. Oh, just a quick point. Again, last thing I'm going to say with this, because it is the last thing I can say. With every single one of your maximum problems, it will be a show. The last ones will be a show. So it will be a show. The reason why they ask you to show is because if a student couldn't show, they can still do find the minimum, stationary points, nature, if they need to do that. So I told my students, there's no reason why you lost, let's say, 6 or 4 marks if you couldn't do the 2 marks above. Maybe sometimes, in fact, I've seen students do IV before they've even done triple I. Smart. They don't even need to worry about triple I. They don't care what the question is. You don't have to make your equations. It's given to you. Just go and do your stationary points in nature. Lock the marks in, and then go back up. Why do I say that? Some of you guys come back and say, Sam, I ran out of time, I couldn't do the 4 marker. Why did you lose marks? Oh, because I was working on the other one, trying to get my equations. Why? When you could have gone and got marks first, and then came back and got stuff. So, exam strategy. All right, that's it. Let's get started. DC, find the minimum cost. We've got to do our stationary points. DC on DX. I'm not going to use this version. I just don't like it, yeah? There's 1,000 outside. I hate that 1,000 outside. I'm going to use the version that we used above here. I like this version. It's already expanded. I don't like it like this. I think you guys wouldn't either. You don't want numbers in front. It'll complicate your derivatives. dc on dx. Oh, here we go. Again, if that's complicated for you, well, does anyone know how to differentiate the first one? This one here? Yeah, see, I was worried you might say that. If you're going to do product rule, it needs to be two x's.
Yeah, there is two. Well,
Two x's multiplied together.
yeah.
Sorry, there aren't two x's multiplied together, right? That's a times. Sorry, and that's an x, if that's what you're thinking. So I think, just expand. Expand this first. So that becomes 5,000 minus 5x. Sorry, 5,000 minus 1,000x plus 2,600. And then again, what am I going to do with my surd? Power of a half. There we go. Now that looks like something I can use. Because what's the derivative of 5,000? 0. What's the derivative of negative 1,000x? Negative 1,000. This guy here, you bring the half down. You go to the power of negative half times the derivative of the inside. Anyone have any questions? Just have a read of that first line. Joe, are you okay with that chain rule there and everything? Yep. Cool. Nice and easy. Yes? Oh, good.
Do we put that as a...
Yeah, remember, because what you're trying to do, you're going to solve it, right? Because you want to solve it, yeah, you don't want to deal with like negative indices. So here we go. Equals 0 technically. Negative 1,000 plus 1,300. Well, stop. 1,300 times 2x is 2,600 x on x squared plus 9 to the power of a half. I can see how this was the 9,900. All right, let's go. You've got to start thinking like this, you guys. It will really help you with your other topics. Okay, what am I going to do? Obviously, multiply everything by the denominator, right? Yeah, the bottom part, denominator. So let's get it out. So what's 0 times this? What's 0? Gone, 0. Beautiful. What's 1,000 times this? Well, it's negative 1,000 x squared plus 9 to the power of a half plus 2,600x. Remember, 9,900. You gotta keep thinking like that. Keep going. All right, we're at this stage. Super weird. It's got a surd and it's got an x. And at this stage, you might think you're wrong, but because like I keep saying, the questions are harder, there's nothing wrong with it. Can anyone tell me something to do? Wait, let's get it clear. There's something that you absolutely must do. So tell me something that eventually I have to do. Well, I can make it into a surd, but that's a problem itself. So what must I eventually do? Well, I eventually want to find x, that's not a problem, but with that right there to solve, what needs to disappear specifically? What's probably the biggest problem there? The surd. Give me a solution. Found the problem. What's the solution to a surd? Square it. So eventually, you know, I've got to isolate it and then square it. Combine both of what you just said. So here we go. I'm going to plus the 1,000 over. We're going to move it over here. And then what am I going to do to both sides? Square it, as you said. What happens? What's 1,000 squared? Well, that becomes 1,000,000. X squared plus 9. 2,600 squared should be 676. 6,760,000 d. Six, yeah, x squared. Should be. That was the hardest step. So that was meant to be really, really hard. Like only top advanced, even extension students would struggle with it. So it's meant to be a really unique question because you have to actually understand the reason why I say it's only even extension students would have struggled because a lot of the extension students would have said, "I'll just square it from here." The problem with that is you're going to have, technically, this is 0 equals, let's just say a plus b. If I square it, what's going to happen? You're going to have 2 times the inside. When you have 2 times the inside, you're still going to have a third. 2 times the third. You're stuck again. So you have to actually isolate it. It's a great word that you use, Eden. You don't want, I think what I usually call them when we do it at like the extension levels, I just say, when you get to these styles of questions, uglies on one side, nice ones on the other side. So if they don't look good, put them on one side. They look good, just keep them on the other side. And you're good. Expand, simplify, solve for x. I think the next few steps are easy. That's 1,000,000 x squared plus 9,000,000. 1,000,000 x squared plus 9,000,000 equals 6,760,000 x squared. Take away 1,000,000 from that. I'm not going to rewrite this. That becomes 5,760,000. And I think you guys know what you're going to do. You're going to divide and then, so 9,000,000, yeah, square root, over 5,760, and then square root. Laptop died. Oh, this is your charger, right?
Yeah.
Yeah. Right, is that the one you gave me last time? Problem solved. Answer? Answer is 1.25, if we're not wrong. Cool. So let's go back and see what the heck that means. All right, x. That means as long as x is 1.25, we'll be able to get the minimum cost. That's what it's saying. As long as x is 1.25, you'll actually be able to minimize your cost. Again, pretty unique stuff. Again, you think of a company that's going to employ people to do this, etc. If they can work out the minimum cost, they can save a lot of money. We haven't shown it's a minimum, so we have to do the second derivative. That comes back down to you guys. Do you want to do the second derivative? That's the question you say, yeah, no. You do not do the second derivative of this, because if you did, let me just show it to you. If you did want to do the second derivative of this, you have to use a quotient rule. So in this case, y dash table comes into play. So we're going to do nature using y dash table. Let me just rewrite what is it? Negative 1,000 plus 2,600x. Y dash equals negative 1,000 plus 2,600x on square root x squared plus 9. All right. Then we've got our y dash table. X, y dash. 1.25 always goes in the middle. 0 goes at the bottom. Then we choose a number before 1.25. We're going to choose 1. We choose a number higher than 1.25. I'll just choose 2. Or you could have chosen 1.5. All good? Sub it in. Negative 1,000 plus 2,600 on square root of 10 gives you negative 177. We're hoping this one's positive. Negative 1,000 plus 2,600 times 2 on square root of 2 squared is 413. Yes, 442. What does that mean? Negative, 0, positive. It's a? As you should be, because if you go to max, you've done something wrong. The question says minimum. Oh, the question will tell you if it's a min or max. Done. Again, what do we do just before we finish it off? Like that? After stat point in nature, go back, reread the question. It says find the minimum cost. Did you find the minimum cost? Did you find the actual cost? No, you just found when it occurs. You found when x occurs. So you've got to sub it back in. So you'll lose a mark again. You don't answer the question. Therefore, minimum cost is, all right, can someone, yeah. Yep, you must have done something wrong.
You forgot the fill.
X. All those minimum cost. Can someone read out that thing to me? This one? 1,000, 5 minus x. As I write it?
It was subject to that one.
Yeah, because it cost. So 1,000 and then 5 minus x. And then can you tell me what else it was? 2.6, I think.
2.6.
Square root.
1.25 squared.
Plus 9, thank you. And that would be the minimum cost. That's it. No matter what you do, you can't get it any more minimum than that. So let's work out what it is since we're here now. Plus 2.6 root 1.25 squared plus 9 times 1,000. The minimum cost is a nice, on the dot, 12,200. It might look bad right now, but I think when you review it just one time, you'll be like, oh, really? That's all I did? The hardest step, like I said, was that isolating step, like realizing to do that. Otherwise, I think the rest, I think we would have differentiated properly if you guys would have expanded. Actually, I should make that point. If you had expanded, I think you would have differentiated properly. I believe you guys would have done that because I'm hearing it from you guys that you would have. Multiplying, I think you guys would have. It's just the next step I'm not so confident about. And then the rest, pretty stock standard stuff. Sounds good? And that's it. That's your minimum cost ever from P to Q and then Q to S. And it occurs when X is 1.25. New technology means that the cost of laying cable underwater can actually be reduced to 1,100 per kilometers. Determine the path for laying the cable in order to minimize the cost in this. Well, it's trying to say, would it have been faster to just go through P to S, right, directly? Or would it be faster, or would it be cheaper, cheaper, not faster, cheaper to go from P to S, or cheaper to go to P to Q to S, or cheaper go to P to R, and then R to S. Now that you know that it's 1100. Fair enough? So you just literally have to do 3 cases. Nothing for me to do. So here we go. V. Let's work it out. Let's go back up here. V. P to Q. Okay. I might just do it on the diagram. Now that it's 1100, I think I've got here. PS would cost 5.8 times 1100, which equals 6414. 64,000, where are we? Sorry, not 64, 6,414. PR to RS. PR, my little pen, yeah. PR and then RS would cost 5 times 1,000 plus 3 times 1,100, which is 8,300. So that's silly. You wouldn't do that one. Yep. Agreed. Last one you would try is PQ to QS. Let's try it in blue now. PQ to QS. To do PQ to QS, you've got to go again. The reason why... Yeah, remember I said 9900. You got to understand what 9900 means. I didn't say band 6. That means state rank, right? You came first in the whole state. Right? That doesn't mean like a 1 mark is 1 mark. 1 mark can take 3 pages, it's fine. It doesn't. I'm just saying, you got to understand that. It's okay, because 1 mark, it's your final exam, it can be long. Extension kids sit your paper. So there's got to be something that's going to be a little bit harder to challenge those guys as well. So, we've got to do the thing again. Instead of it being 2.6 here, what number do you choose? 1.1, because it's 1100 now.
Do the same thing.
Do the same thing. All right, V. I'm just going to quickly do the math. It's going to look like this. 1,000. Five minus x plus 1.1 square root x squared plus 9. When you do your C dash, so C equals, for PQ and QS, by the way, this is PQ and QS. You'll eventually get to x equals 6.54, but what's the problem with x being 6? What's the maximum distance you had from P to R? 5. So since that will never occur, x is less than 5. Cheapest path is PS, the one we found above. Make sense? The one we found above. Because PQ to QS doesn't work.